In a newly published paper, Virginia Tech geoscientists have found that shallow wastewater injection, not deep wastewater injections, can drive widespread deep earthquake activity in unconventional oil and gas production fields. Brine is a toxic wastewater byproduct of oil and gas production. Well drillers dispose of large quantities of brine by injecting it into subsurface formations, where its injection can cause earthquakes, according to Guang Jai, a postdoctoral research scientist in the Department of Geosciences, part of the Virginia Tech College of Science, and a visiting assist. The findings appear in the May 10 edition of the Journal Proceedings of the National Academy of Sciences. Joining Jai on the paper are Manucher Shirzai, an associate professor of geosciences at Virginia Tech, and Michael Monga, a professor and chair of Berkeley's Department of Earth and Planetary Science. In the U.S. Department of Energy-funded study, the team focused on the Delaware Basin in western Texas, one of the most productive and unconventional hydrocarbon fields in the United States. Since 2010, the basin has experienced a significant increase in shallow wastewater injection and widespread deep seismicity, including the recent 5.0 magnitude event near Mentone, Texas. Most of the earthquakes were relatively small, but some have been large and widely felt. It is quite interesting that injection above the thick, overall low permeability shale reservoir can induce an earthquake within the deep basement, despite a minimal hydraulic connection, Jai said. What we have found is that the so-called poroelastic stresses can activate basement faults, which is originated from the fluid injection causing rock deformation. Poroelasticity is the resulting interaction between fluid flow and solid deformations within a porous formation, here sandstone. This finding is significant because it puts poroelastic stresses in the spotlight as the main driver for basin-wide earthquakes in the basin, said Shirzai, who is also an affiliated faculty member of the Virginia Tech Global Change Center. Yet, predicting the amount of seismic activity from wastewater injection is problematic because it involves numerous variables, one of which is injection depth, Jai said. Although it is well known that fluid pressure increase due to deep injection is the dominant reason for the recent seismicity increase in the central and eastern United States, it is still questionable exactly how shallow injections cause earthquakes. During the study, the team looked at how varying amounts of injected brine perturb the crustal stresses deep under the Delaware Basin and how these disturbances lead to earthquakes on a given fault. Added Jai, fluids such as brine and natural groundwater can both be stored and move through rocks that are porous. The trio used data analytics and computer modeling to mimic the large volume of fluid extraction from shale reservoirs from more than 1,500 shale production wells during 1993 Thanks for watching. Please subscribe my channel for more updates.